So as you look here at this page, what we're going to mainly get to is talking about how things exist in water. Do they dissociate in water and become something different than their chemical formula indicates, or do they remain a neutral molecule and they're just, the particles are kind of floating around in water as they are? To get to that classification scheme, we're going to first start with classifying materials into one of 5 categories. Is it an acid, a base, an aqueous salt, a weirdo, or is it none? All right, and the reason that they have chosen those 4 or 5 terms in that order, well, I guess not really anymore. I added the none myself. It used to be spell the word. What used to spell the word? No. Okay. This has absolutely nothing to do with what I'm talking about. This is the whole page I have added. My bad. So this classification scheme will be useful for you in terms of thinking about how things tend to behave. So if I were to give you the name of a compound, how would you know that it was an acid? It says acid. So the name includes the word acid. And and the writing's not good today, I know. If they give you a formula, the formula starts with H and then has something after it. Or, and this is going to be new, ends with, so we're going to have something preceding, and it will end with COOH. And again, this is kind of like that ethanol and methane thing. We're going to talk about this group of carboxylic acids in our next unit, but this just kind of fits better here. So if you look at a chemical formula and you identify either of those 2 things, it's an acid. Bases have characteristic properties that are of acids. Acids and bases are opposites of each other. The name of bases don't include the word base, though, like the name of acids include the word acid. So you can't identify it that way. Bases are XOH, where X is a metal ion. So any ionic hydroxide, sodium hydroxide, iron hydroxide, whatever hydroxide, that is a base. The second category of things that are bases are called amine bases because of the presence of nitrogen. So it's going to be something. This is kind of analogous to the something and then it ends with COOH as an acid. If you have something and it ends with an N, and then it could also have some hydrogens on the end of it, this is referred to as an amine base. For example, that one that I just told you to know, NH3, ammonia, is a base. And we're going to talk some more again about these things in terms of in our next unit about organic chemistry. Where you guys have been hearing this term about biology with amino acid, where as you talk about your amino acids, one end of the amino acid is a carboxylic acid, and the other end of the amino acid is an amine group. And so you get a bond between the amino group and the carboxylic acid group and another amino acid, and that's how you link together your amino acids to make proteins, is a bond between the amine group in one and the acid group in the other. So that's kind of a biology connection there for you, if you like. The third category is aqueous salt. Something is an aqueous salt if it is a salt. Now, when you say salt, you can't mean sodium chloride. Sodium chloride is table salt. The term salt in chemistry is a lot more broad than the term salt is used in everyday language. That's usually opposite. Usually we mean something very specific in science, and other people use the word to mean something much more broad. But here it's opposite. When people say the word salt, they're thinking of what comes out of the Morton salt bottle and they shake on their food. When chemists say the word salt, they mean an ionic compound that is not an acid or base. Okay? So it doesn't start with hydrogen. It doesn't end with hydroxide, but it's an ionic compound. So remember, you identify an ionic compound as being something positive or negative. Aqueous, what does aqueous mean? It's dissolved in water. So when you dissolve that ionic compound in water. And most of our chemistry that's going to be discussed next year is aqueous chemistry, aqueous solution chemistry. Then we have weirdos. Weirdo is not an actual chemical classification. Okay, this is kind of a made-up little term that is going to address 3 particular chemical compounds that behave differently. They are things that you would typically classify as acids, these two, H2SO3, which is sulfurous acid, H2CO3, which is carbonic acid, and the one thing that you would typically classify as a base if I weren't giving you this other classification instead, H4OH, which is ammonium hydroxide. Then the 5th category, and most substances are really going to fit into the none category, but these other classification systems are important in aqueous systems, but none is most stuff. Most things, things that are none are ones that don't fit in these categories. They can be elements. They can be, I'm going to put most on here for your purposes right now. You can think of that. Most covalent compounds. So things that do not have positives and negatives. Carbon dioxide. Water. Water would be a none. That ethanol thing, C2H5OH, that would be a none. Okay? So what I would suggest you do is pull this page out of your binder, and then I'd like you to turn back to page 17 with me. So what we're going to practice doing is looking at these names and formulas and classifying the materials as acid, base, salt, weirdo, none. And yeah, you can use a letter, A, B, S, W, N. I'm fine with that. That's no problem. So what I do with ammonium sulfate is I can look at that formula and I look at my list. You just kind of start at the top. Does the name end in acid? No, it's not an acid. For the base, you can say, well, does it include hydroxide? No. Does it include, does it end with NH something? No. So it's not a base. And then when you get to the aqueous salt column, it says, is it an ionic compound? Did you say ammonium was plus something and sulfate was minus something? Yes. So that's what makes it be a salt. All right? Magnesium chloride. Is it an acid? No, the name doesn't say acid. Is it a base? Does it end with hydroxide? No. It does not end with the word hydroxide. It does not end with OH. Right? So that's a salt because this is positive, this is negative. But it's not, a hydrogen is not the thing that's positive. The hydroxide is not the thing that's negative. That's correct. Anything that has a name with prefixes in it is going to be a none. Anything that has prefixes in the name would be a none. So what I'd like you to do now is for both pages this time, 17 and 18, complete the acid, base, salt, weirdo column.